Okay, we're going to introduce parallel lines and perpendicular lines. So on this one, I'm going to start with the blue line, okay? So first, let's find the y-intercept. So the y-intercept is 2. And then we're going to find the gradient. And again, please do use a ruler in your exams. But 2 high, 2 wide. My gradient is 2 divided by 2 is 1, okay? So let's put this all into an equation. So this blue line has got the equation y is equal to 1 lot of x, so we're just going to write x, and then plus 2, which is our y-intercept. Okay, so that's our blue line. Now, from before, we should have recognised that we've got the same number in front of x with a parallel line. Okay, so we, for instance, had 2 parallel lines in the previous example. So let's have a look at this purple line. You can visually see this looks like it's going to be parallel, but let's just do the double check. So again, let's start off with the y-intercept, which is -3. And then we're going to look for the gradient. And again, please do use a ruler in exams. So this is 3 to 5, so this is obviously going to be 2 high, and also 6 to 8, 2 wide. 2 divided by 2, our gradient is 1. So we can see we've got the same gradients. If we've got the same gradients, they must be parallel. So the equation here is y is equal to 1x, so just x, and then subtract 3. So those two we know to be parallel. Why? Because they've got the same multiplier in front of x, so it's a 1 in this case, which we don't write, but there's still the same number of x's. All right, so that's our parallel line sorted. The green line is clearly not parallel. In fact, the green line crosses both of our lines at a right angle, okay? We call these perpendicular lines. Now, if I was told that this line is perpendicular to my previous line, I was asked to give the equation, I can do that using the same method as before. So obviously seeing where it crosses the y-axis, so that's nice and easy, it's crossing at 4. And to find the gradient based on the previous gradient of our blue line, for instance, I take the gradient I've got, which is 1. Now 1 as a fraction is 1 divided by 1, okay? Now when you want to find a perpendicular line, and this is maybe not the best example to start with, but just still, what you want to do is make the reciprocal of the fraction, and you want to make it the negative version. So ours was positive 1, which is 1 divided by 1. So what we're going to do is we're going to change that to negative and make it the reciprocal. Reciprocal just means turn it upside down, okay? So now we end up with -1 over 1. So our gradient is -1, okay? So this little bit over here was just what's happening, really. Okay, so we've got a gradient of -1. Let's pop that over here. So the equation for the green line is y is equal to -1x, so negative x, again we don't write the 1 in, and then add 4. Okay, so let's have a look at an example where we can see that reciprocal a little bit more obvious for the perpendicular line. So let's start with the blue line again. So we've got a y-intercept of -4. And let's work out the gradient. So again, please use rulers. Okay, so this is between 0 and 4, so 4 high, -2 and -4, is 2. Remember, this is a negative gradient, okay, sloping from the top left to the bottom right, so our m is -2. Our equation of the line, therefore, is y is equal to -2 lots of x and then -4 for the y-intercept. Okay, so that's our blue line. Our green line is clearly the one that's parallel. It's running alongside, never crossing. Okay, that's the important part. It's never going to cross our blue line. So let's have a look. We should know already, and we should be able to just go straight ahead. Our parallel line is going to have a gradient of -2 because it's parallel. So I can start off with y is equal to -2 anyway. Okay, don't have to do much more thinking than that. The next thing I want to do is identify the y-intercept for this particular line, which is at +2. So then I have to put +2. Okay, see how quick that was because I knew that it was parallel. Right, let's then have a look at our more complex little friend down here, which is our purple line. Okay, now purple line, as with the previous example, is at right angles to our other lines. Okay, so again, what we could do is, and I'll show you, is work out the gradient itself. So dot, 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 1 high, 2 wide. So the gradient is a half. So we already know that. But let me show you how I do it. Just using the gradient, knowing that it's perpendicular to our blue or green lines, okay? So take the gradient of our blue or green line, which is -2. -2 divided by 1 is like this. Then you're going to switch it over, so you'll flip your fraction over, so it becomes 1 over -2. But you're going to make it the negative version of the fraction you already had. So it was already negative, so I need to take the negative away. So if it was negative, you make it positive. If it was positive, you make it negative. So you can see that that is also a way of finding the gradient for a perpendicular line. Okay, so then we've got the last little bit, which is to identify the y-intercept. And actually, I've inconveniently... So I need to find that y-intercept, which is down here at -3. So C equals -3. Now let's put that all together. So y is equal to half x minus 3. And that is our perpendicular line. Okay, good luck and have a go.